Hi everyone, welcome to the 8th lesson of our 4th unit in Science 10, and this is Climate Change, Evaluating the Evidence. In this lesson, we are going to be looking at things like changes in greenhouse gas levels, how humans have played a role in the changing of greenhouse gas levels. We're going to look at the enhanced greenhouse effect, global warming. And as you know, global warming has been quite a topic in the news lately, a lot of discussion around that. And hopefully after this lesson and this unit in general, you will have a greater understanding of what everyone is talking about. All right, let's move along. Now, changes in greenhouse gases. Earlier in this unit, we learned that the natural greenhouse effect keeps our planet warm by absorbing some of the thermal energy radiated by the Earth's surface. The natural greenhouse effect is due mainly to the presence of water vapor in the atmosphere. There are other greenhouse gases that play a significant role. The four main gases are water vapor, which we already mentioned, carbon dioxide, methane, and nitrous oxide. Now, I want to just say this here. You have to keep in mind, we talked about the natural greenhouse effect earlier. That is in place. That is a good thing. We need that on planet Earth, okay? And basically what's happening is, remember, if you remember correctly, the natural greenhouse effect essentially helps balance the amount of incoming energy from the sun with a certain amount of energy leaving the Earth. So in other terms, remember, we always have energy coming in, and we always have a certain amount going out. And this means that the total energy on Earth remains balanced. You might also recall the net radiation budget. So just again, natural greenhouse effect is good. It helps keep the temperature or the amount of energy on planet Earth balanced. Now, I'll keep going here. Analysis of ice core samples from Greenland and Antarctica and of atmospheric data has led scientists to conclude that atmospheric concentrations of carbon dioxide, nitrous oxide, and methane have increased over the time period of about 1700 to 2000. Since greenhouse gases absorb heat, changes in the levels of these gases could change the net radiation budget of Earth. Increased greenhouse gas levels could mean that less thermal energy is released back into space, and the average temperature of Earth's surface could increase as a result, which is what I'm talking about. Oh, by the way, these little diagrams here just show how CO2 has gone up since the year 1700, nitrous oxides and methane. So just remember the natural greenhouse effect. Well, that was the balance. So if you take, this is our red Earth. Remember, we had energy coming from the sun, and that's always coming in. But naturally speaking, some of that energy was also allowed to go back into space. There was a balance, okay? A balance of what's coming in versus out. What we're saying here, especially in this last bullet, increased greenhouse gas levels could mean that less energy is released back into space. So think of that now. If I do a really basic example, if I give you a number, let's say now we have 100 joules of energy coming in. In the past, we should have 100 going out, which means we have a perfect balance. But if these greenhouse gas levels increase, we might now, let's say, only let 80 joules out every day. So that means on a day we have 100 in, only 80 out. That means for that day we're plus 20 joules of energy. And that would happen the next day and the next day and the next day. And of course that is going to lead to an increase in the temperature of the surface of the Earth. And this is the concern. We don't no longer have a balance. We are going to be going up each day. Now, I'm going to give you all a hint. What we are talking about here on this slide is going to be on your quiz. It's also going to be on your unit exam, so very important. Greenhouse gases and human activity. The rise in greenhouse gases since the start of the Industrial Revolution in the late 18th century is a direct result of changes in human activity. So you have to think, the Industrial Revolution is a big change for us. During this time, human society became more dependent on fossil fuel consumption. In other words, we started burning fossil fuels. And as you can see, fossil fuels are coal, oil, and natural gas. Fossil fuels are fuels that contain large amounts of carbon. Now, that were formed from the remains of living organisms. So we know about this. The coal, the oil, the natural gas, that is made up of carbon from old living organisms. We don't need to get into that too much right now, but the point is coal, oil, and natural gas contain huge amounts of carbon that used to be part of living organisms. This is important. Burning fossil fuels releases carbon dioxide and nitrous oxide into the air. Okay. Any process that releases carbon dioxide into the atmosphere is called a carbon source. So a carbon source is anything that releases carbon dioxide. I'll give you two examples there. You have the burning of fossil fuels or respiration of living things. What do I mean by that? Well, what are you breathing out right now? When you exhale or breathe out, you are releasing carbon dioxide. So that's an example of a carbon sink. So now, you really have to think about this. Sorry, I went forward there and I shouldn't have. I want to be clear. In the Industrial Revolution, the way humans, lived changed. Now we figured out that we can burn fossil fuels, and when we do so, we can run machines, we can have machines do things for us. It's great. But the problem is when you burn fossil fuels, you release huge amounts of carbon dioxide and nitrous oxide into the air. So this is a huge change. I want you to be aware of that. Industrial Revolution means we burn more fossil fuels, which means we put more carbon dioxide and nitrous oxide into the air. Those are greenhouse gases. Now, let's move on. The second part. At the same time as the Industrial Revolution, people were migrating into wilderness areas and clearing land of forests or any kind of natural land to provide timber for fuel and construction and to prepare areas for agriculture. Forests or natural areas play an important role in removing carbon dioxide from the air through the process of photosynthesis. You see, photosynthesis is a natural process that removes CO2 from the air. See, that's a good thing. Photosynthesis is a carbon sink. A carbon sink is any process is any process that removes carbon dioxide from the atmosphere. The loss of forest cover during the last 2 centuries reduced the size of Earth's carbon sinks and therefore decreased the amount of carbon dioxide being removed from the atmosphere. Lack of balance. Okay, so let's put this all back into perspective. We know, let's focus on carbon dioxide. Carbon dioxide is a greenhouse gas. We know from one slide ago that during the Industrial Revolution, we started burning fossil fuels. So we're putting way more CO2 into the air. Okay, so that's one way that we are increasing our greenhouse gases. At the same time as the Industrial Revolution, and to this day, now humans are spreading. And what we're doing is we're cutting down natural areas. Well, what do the natural areas do? Natural areas, which are plants and trees and so on, they carry out photosynthesis. And naturally, they take in carbon dioxide. Well, we're cutting that down or destroying it. So on one hand, we are putting more CO2 into the air, and at the same time, we are eliminating the one thing that could potentially take in that CO2. We're getting rid of that process. So do you see how it's kind of we're increasing greenhouse gas levels in 2 ways. We're putting more into the air by burning fossil fuels, and we are eliminating or cutting down or just covering up the one thing on Earth that naturally could take in that CO2. So we no longer have a balance in the amount of CO2 in the air. I hope that makes sense. Now, greenhouse gases and climate change. Most scientists have concluded that the increased emission of greenhouse gases by human activity has influenced global climate. The enhanced greenhouse effect is the change in Earth's net radiation budget caused by the increase in human-generated greenhouse gases. Temperature data collected from the world shows that the global average temperature has increased by 0.6 degrees from 1880 to 1999. This time span was also the period when changes in human activity, such as those of the Industrial Revolution, increased the amount of greenhouse gases emitted to the atmosphere. And further to this, you may have even heard the last few years we've been experiencing some of our hottest summers. The evidence, I'll let you look into that. But there is a general consensus that the temperature on Earth is going up. So I actually wanted to use this diagram right here to kind of just summarize one last time what's going on. So I want you to think of the natural, I'll get off the eraser. Let's do the natural again. Natural greenhouse effect. That is the good one. We like this one. So again, I want you to remember. So right here, see this yellow line right here? That is the energy from coming in from the sun. So let's say there are 100 joules coming in. That's how important this is, because remember, it's on your quiz and your exam. Naturally speaking, every day, let's say, every day on Earth, 100 joules of energy comes in. Well, before humans started messing with the balance of greenhouse gases, we would have lost 100 joules back into space. There was a balance. You see, every day we had a similar amount coming in and a similar amount going out. Life was good. That is a balanced approach where the temperature of the Earth as a whole does not go up or down, it just remains constant. Now, let's do the right back here, okay, the enhanced greenhouse effect. Now for the enhanced greenhouse effect, greenhouse effect, this is the one that we don't want. So what's happening here now? Well, energy is still coming in from the sun, so we'll keep it simple. We'll say that every day there are 100 joules coming in, okay? Now, what did we learn? During the Industrial Revolution and ever since, we have been burning fossil fuels, which means that the amount of especially CO2 is building in our atmosphere. Now, that greenhouse gas, along with others, what does it do? Well, the 100 joules keeps coming in day after day. We can't change that. Now, remember before, if we let 100 in, 100 should get out. But what I'm saying to you is, as the concentration of those greenhouse gases builds in the atmosphere, less and less energy is allowed to leave. So let's just say, I'll use it again. Let's say right now that now we only let 80 joules out. So what does that mean? How much are we up for the day? Well, if we let 100 in and only kick 80 out, that means for the day we are plus 20 joules. And that would happen tomorrow and the next day and the next day, which means we are adding energy to the Earth. And for what it's worth, as humans keep burning fossil fuels, we are releasing more CO2 and greenhouse gases into the air. Furthermore, we're cutting down more trees, we're cutting down more natural area. We are eliminating the one thing that could suck in or consume that CO2. So the idea is the amount of greenhouse gases in the atmosphere is actually going to build. So that means less and less of this energy is going to get out. Maybe it's 70, maybe it's 60. Anyway, the point is there's no longer a balance. What we have coming in is no longer equal to what's going out, and it's getting worse. And that's why you got global warming or the enhanced greenhouse effect. Okay? I hope this makes sense, and I'm telling you again for the third time, it's on your quiz, it's on your exam. You have to understand the contribution of the Industrial Revolution and the impact of clearing forests or natural areas on the increasing temperature of the earth. It is worth a lot of marks on that quiz and exam. Please read the textbook and please understand what's going on here, and best of luck.